Okay, good day. This is Math 130 Intro to Statistics. I'm Professor McCulley. This is lesson number 23, Hypothesis Testing for Proportions. Let's get right to it. There's only one learning goal today. That is to use the Z-test to test a population proportion P. Now, I have to tell you right up front that even though there's only the one learning goal, we're going to take everything that we learned in lesson 22 about hypothesis testing. We're going to take that list of 7 or 8 steps that we learned to apply it to a population proportion. We're going to verify our assumptions. We're going to write our alternative and null hypothesis based on whatever the claim is. We're going to go through the level of significance. We're going to determine critical values. We're going to talk about our rejection regions. We're going to find the standardized test statistic by using with the calculator, and then we're also going to use the calculator to do the alpha value, and then we'll make a conclusion at the end. So our z-test for a proportion P is a statistical test of a population proportion. The z-test can be used when a binomial distribution is given such that NP is greater than or equal to 5 and NQ is greater than or equal to 5. If you remember, we need to be able to say that this is true so that the binomial binomial can be approximated with a normal curve. The test statistic is the sample proportion p hat, and the standardized test statistic is going to be a z-score. And so that z-score is given as calculated by p hat minus the population proportion divided by the square root of the population proportion times the complement of the population proportion, all divided by the number of values in the sample. So the guidelines, these are specific to a population proportion versus the 7 that we talked about later, but just want to make sure that they link up fairly well. There are a few little tweaks for population proportion, but that list is basically the same. And the first thing we want to do is we want to verify that the sample, and I apologize for this, this should be sampling. Let's do that right there. The sampling distribution of p hat can be approximated by a normal distribution. And so we need to show that NP is greater than or equal to 5 and that NQ is greater than or equal to 5. We need to state the claim mathematically and verbally. We need to identify the null and alternative hypothesis. We talk about the level of significance that's probably going to be given. We're going to determine the critical values either by a table or the inverse norm. And then we're going to determine the rejection areas, and we'll draw a picture about that. We'll find the test statistic and sketch the sampling distribution, and then we'll make a decision to reject or fail to reject the null hypothesis and interpret the decision in the context of the original claim. Okay, example number 1. A researcher claims that less than 30% of all cell phone users in North America use their cell phone for most of their online browsing. In a random sample of 150 adults, 23% say that they use their cell phone for online browsing. At the alpha equals 0.1 level, is there enough evidence to support the researcher's claim? All right, so let's go through all of the steps here. The first step says we need to verify that sampling distribution of p hat can be approximated by a normal distribution. So let's go through and do that. So number 1, verify. Why do I put F there? I don't know. verify normal approximation. All right, 2 P's in approximation. Sure, we'll go with it. All right, so I need NP. Now, N was 150. In this case, P is 0.3. And if I do that calculation, I get 45, which is clearly greater than or equal to 5. And then if I go NQ, I'll get 150 times 0.7. Now, since 0.7 is bigger than 0.3, clearly our value is going to be bigger. But when I do that calculation, I do get 105. And again, both of these are going to be greater than 5. All right, so the second step, what's the second step? It says state the claim mathematically and verbally, and then identify the null and alternative hypothesis. All right, so it says a researcher claims, there's our claim, that less than 30% of all cell phone users in North America use their phone for most of their online browsing. Okay, so we need a null hypothesis and we also need an alternative hypothesis. Now, since the claim is a straight inequality. The claim is that the population proportion is less than 30%. That is going to be, we're going to place that because it's just a inequality. We're going to say that our proportion is going to be less than, we don't want, definitely don't want equal to, sorry about that, is less than 0.3, 0.3. And then our null hypothesis will be the opposite of that. So P greater than or equal to, and it has to include an equality, 0.3. And just to keep track, we'll put the claim right there. Okay, we're to number 3. Number 3 says, specify the level of significance. That's pretty easy. We know that to be 0.01. Number 4 says determine the critical values either by a table or inverse norm. All right, so if I want to do a, and so let's think about what we got here. All right, so again, we test the alternative hypothesis. So our z-score here is where we get, and I'm sorry it doesn't go down there, but this is going to be an area of 0.01. All right, so this z-score is clearly going to be negative. And if we go to use a table here, if you look right here on this particular table, come on now, do it right. This is the closest value I get to 0.01, 0.099. Now, if I round that up, I get to 0.1. This one is actually a little bit further away from 0.01. It's close, but this number here is bigger, is further away than that one. So we're gonna stick with that. And so our test statistic in this particular instance would be negative 2.33, and that would be our critical z-score. So it would be negative 2.33. Now we could also use an inverse norm. And so if I grab my graphing calculator and go second, the distribution table hit 3 for inverse norm. We want the area to be 0.01. We put all that stuff in and paste. And here, negative 2.326, that would round up to the negative 2.33. But we're going to be a little bit more accurate, and we're going to say that it's negative 2.3263. And so our Z critical, negative 2.326, let me check it one more time, 263. All right, we've done that. Number 5, determine the rejection region. And so our rejection region for this particular instance will be anything that's going to be less than this value right here. And so anything that's less than negative 2.3263. Number 6 says that we need to find the standard test statistic, and we need to use that equation. So let's go ahead and do that. And just to be clear, our z-score is going to be the p-hat minus the average, the mean of the sample proportions, and this is the standard error of the sample proportions. Now, the mean of the sample proportions is just the value that we're looking for. So p-hat, minus p, and we're still over our standard error. And that is calculated by, you know what, let's move this one forward a little bit. And this is calculated by the square root of n, not n, square root of p times q all over n. So we've got 0.23 that came from the problem, and 0.3 that also came from the problem, all over the square root of 0.3 times 0.7 all over 150. Now if you do that calculation, you end up with negative 1.871. And so the conclusion that we can make from that is that since this value here is bigger than that value, we would fail to reject the null hypothesis. Now we can also calculate that with an inverse normal, all right, or a normal CDF, excuse me. So we're going to go second, we're going to do the distribution, we'll hit 2, oops, I didn't want that, sorry, let's quit this out, second distribution 2, and so we would have negative infinity. Our upper value here is going to be the value that we calculated, so 0.23, and then all of that goes, and we hit enter. I totally screwed that up. I'm sorry. I don't know what I was thinking. And so we need to go 2.23. Our mean clearly isn't 0. Our mean is the sample proportion, so 0.3. And then we would calculate that using that standard error. The standard error we said was the square root of 0.3 times 0.7 all divided by the sample size of 150. If I hit enter now, I want to paste that in there. There we go. That's a little bit better. And so let me pull that back up. We could also go inverse norm. No, come on, get with it. I got these all going wrong, and I'm sure I'm confusing you, and I apologize. Normal, and just real quick, we're trying to find an area, and when you're finding an area, it's the normal cumulative distribution formula, and I apologize. So negative infinity, we had negative 1 times 10 to the negative 99th. In this case, the value that we're testing is 0.23. The mean, and again, this is our sample proportion, would be that. Our standard error, square root of 0.3 times 0.7 all over 150, and we got 0.307. Oops, go back to that. 0.0307. All right, and clearly this is bigger than our alpha level. So in both cases, in step number 7, we're going to make the decision to reject or fail to reject the null hypothesis. So in number 7, we fail to reject the null hypothesis. And because we are rejecting this, we are going to say that there is support for our claim. And so we can finish this off by saying there is evidence at the alpha equals 0.01 level to support the claim that less than 30% of all North American cell phone users use their phone for most of their online browsing. All right, let's try another one. A researcher claims that 55% of all high school graduates say that they have to have some education past high school. Graduates say that they need to have, or in a random sample of 100 or 500 graduates, 300 say that they need some education past high school at the alpha equals 0.1 level. Is there enough evidence to reject the researcher's claim? All right. So again, and I'm not going to go back and forth just for time's sake, we need to verify. And in this case, we would have our NP is 500. And then P is going to be 0.55, so times 0.55. And if you do that calculation, you get 275, which is clearly greater than 5. And then if we go NQ, that would be 500 times 0.45. Now that's going to be a little bit smaller, but clearly when you calculate 225 here, that's also greater than 5, so that's also good. All right, so thus we can p hat can be approximated by a normal distribution. We also have to note that p is not expressly stated here, so we're actually going to calculate our sample proportion, excuse me, and we do that by going 301 over 500, which gives us to be 0.602. And then step 2 says we need to state the claim mathematically and verbally, and then come up with our null and alternative hypothesis. So our null hypothesis, our alternative hypothesis, and we'll go 1 just because the school has some of those on the test. Our P equal to, because we're saying that it's equal to, is 0.55, and that is the claim in this one. And then the alternative hypothesis P not equal to 0.55. And so now in step 3, we have to talk about our significance level. So alpha equal to 0.1. And then in step 4, we have to find our critical numbers. So in this one, if we think about it on the course of a curve here, because it is an equal to or not equal to, we're going to split this into 2 parts, and we'll have 0.05 there and 0.05 there. So this is our negative z sub c, and this one will be our positive z sub c. Okay, so we already did the table, and I don't care to look up another one, so we'll just go grab our inverse norm, and we know that this is a two-tailed test. And so if I grab my graphing calculator, we're going to go inverse, our second, distribute, we need our inverse norm, so 3, and 0.05, everything else stays the same. We hit enter there, and we get negative 0.6448, 6449, we'll round up there. So this one here is negative 1.6449, and this one is positive negative 1.6449. And we didn't calculate it because we know that even though my graph looks awful, the standard normal curve is symmetrical, and we're trying to find our particular rejection regions. So we would reject the null hypothesis if we had a z-score that would be less than negative 1.6 or greater than positive 1.6. All right, so we kind of did 5 there. Let's find our standardized test statistic, and we'll jump right ahead to it. We'll say z is equal to p hat minus p over the square root of pq all over n. In this case, we came up with 0.62 or 0.2 minus 0.55 all over the square root of 0.55 times 0.45 all over the sample size, which was 500. All right, now if you go ahead and you calculate that, you end up with 2.337. Now clearly 2.337 is much, much larger than that value. You can also do a normal CDF, and we'll use the values that we have. All right, so we're just going to calculate it. It would be negative infinity to our calculated p hat, which was 0.62. I think that's right. What did I come up with? I need a 0.2 there. Sorry. 0.602. The value that we're looking for, which was 0.55, and then our standard error, which would be the square root of 0.55 times 0.45 times or divided by 500. Now, if we go ahead and do that, so second distribute, and then our normal CDF, we go from negative infinity to let's see, what did I say? 0.602, thinking our value there is 0.55, and then our standard error, which is 0.55 times 0.45 divided by 500, and then we want to paste that in, and we get 0.9903. All right, so if we're thinking about this upper one, if this is 0.5, and I don't know why I put a Z there, there should be 0.5, then this value down here would be 0.99, or excuse me, 0.95. Apologize. 0.95 as far as that total area goes, and clearly a value of 0.9903 is greater than that. So in that particular instance, we would reject the null hypothesis. All right, and so from that, since the claim is in the null hypothesis, the way we would write this one up is we would say there is statistical evidence at the alpha equals 0.1 level to reject the claim that 55% of high school graduates say that they need some education past high school. Now, I can't say that it's more than 55% because that's not what I tested. And so if you wanted to say that it was bigger than 55%, you're going to have to go through and do that whole test. That's all I got for today, folks. So our fun fact, Marvel fun fact of the day: the creator created by Thor's hammer in the first Thor movie has the same design as Captain America's shield. So the hammer is right there, and you can see the concentric circles just like you do there. That's all I got. Have a good day. Bye.